The next of our three rules for electron configuration is known as Hundt's rule. And the basic idea here is that when configuring the electrons into the orbitals, orbitals are filled up with single electrons first, and then the electrons are only doubled up. You only get 2 electrons if you need to, if there's no more space for electrons. So imagine that we have 4 electrons, and they're going to be configured into the 2p sublevel, energy level 2, sublevel p, with 3 orbitals. Again, we're going to use boxes to represent orbitals. According to Hundt's rule, we would do this. We would fill the orbitals with single electrons first. So it would look something like this. For this final electron, we would go back to the first orbital and fill that in with a second electron. So for 4 electrons here, one of our orbitals will be filled. That's Pauli exclusion principle. We can only have 2 electrons max in any orbital. These other 2 orbitals will have single electrons. The idea behind this is that since electrons are negative, they tend to repel, and they will spread out if they're able to do so. Remember that like charges repel, electrons do tend to repel each other. According to Hundt's rule, you would not do this, because there is room now. We have an empty orbital into which these electrons can spread. So instead, according to Hundt's rule, the electrons will go into the orbitals as single electrons if possible, and then only double up if they need to. That's Hundt's rule.